Folks, here we go. New chapter, new unit. We're going to start talking about functions. What we want to be able to say by the end of today's lesson are the two things up here at the top. I can determine whether or not a relation is a function, and also I can compare functions that are expressed in different forms and understand what each function represents. Let's just get right into it. Let's start with a couple definitions here. You're fill in the blanks. So, folks, a relation, it's any set of ordered pairs. If you want to throw out any number of ordered pairs, if you throw out one ordered pair, like if you look down here, number 1, negative 2, 1, if it's just by itself, that's a relation, because you could say that's a set. If you took all four of these numbers, all four of these ordered pairs, you would say, hey, this is a relation, because it's a set, it's a grouping of ordered pairs. And in this case, there are 4 ordered pairs. There could be 1,000 ordered pairs. As long as you have a set of ordered pairs, we would say that that whole set is called a relation. Okay, let's continue. A function is just a special type of relation, okay, in which each member of your domain is paired with exactly one member in the range. What the heck does that mean? Well, your domain, those are your, and maybe I should be writing here, those are your x values. Your domain is the name of the group of all your x values, and the range is your set of y values. Okay? So, once again, if you come down to example number 1, your domain in this example is going to be all your x values. It's going to be negative 2, negative 4, negative 5, and negative 1. So, and your range values, I'll do those in red, are going to be all your y values, 1, 3, 4, and 7. Okay? Now, let's just jump right into example 1. What I didn't write here, the directions, I would have probably said, hey, please tell me whether each of these 3 relations is a function. So we know that this is a relation and this is a relation, and I'm going to graph your points here, and it's going to be a relation because this thing right here, this set of ordered pairs, and this mapping and this graph are merely representing a set of ordered pairs. Negative 2, 1, negative 4, 3, negative 5, 4, and negative 1, 7. It's definitely a relation. It's a set of ordered pairs. So the question is it a function? Well, how do we figure that out? Does this set of ordered pairs meet my definition of a function? So, does each member of my domain do all of my x values, the ones underlined in blue? Are they paired with only exactly one member in the range? So this x value, negative 2, is only paired with one y value. Do you see negative 2 in any of my other x positions? No, you don't. So that's good. That means my negative 2 is only paired with one number. Same thing with negative 4, same thing with negative 5, same thing with negative 1. If by chance you had a 5th ordered pair and it said, I don't know, like negative 4, 6, well, guess what? Negative 4 is one of my domain values, and you see it in 2 spots, and it's paired with different y values, different range values. So if this was our relation, you would say, no, this is not a function. However, since that's not your relation, since your relation is what I gave you, you would say, yes, this is a function. Yes, function. And we'll do another example in a second where we actually have to give a better explanation than that. Now, this is a mapping. This is another way to represent a relation. Okay? So, these are the same numbers that you see right over here in your set of ordered pairs. Negative 2 is paired with 1, so we just draw a line. Okay, negative 2, 1, we just draw a line from negative 2 to 1. And negative 4 to 3, because those two are paired up. And negative 5, 4 is your point right here, so you got to match those up. And negative 1, 7 is right there, so you got to pair those guys up. this right here is just a different way of expressing what you have here. Some people like the picture more than seeing the ordered pairs. So in order to tell me whether this is a function, which you already know it is because we already said that over here, but if you hadn't seen this over here on the left, let's pretend we didn't know that was there, and we were just given this, and we were asked, is this a function? Is this relation a function? You would tell me, well, since each of my domain values, my x's, these guys, only has one line coming from it, because each of my x's is only attached to one y value. Since each of my x's is only attached to one of these y values, guess what? This relation is a function. Okay, now if perchance we added -4, like over here we had -4, 6, I added that one in. If that was here, you would also have to have -6 over here, and you would also have to draw a line from -4 to that's +6, from -4 to 6. Guess what? It's very easy to tell whether this is a function or not. If one of your x values, your domain values, has two lines going from it, it's not going to be a function, because that means that one of your domain values is paired with more than one member in the range. And this is the important part right here. If a relation is going to be a function, each of its x values can only be paired with one y value. Now let's come over to the graph. This is the third way of representing, of showing a relation and determining whether it's a function or not. So let me graph these for us. 2, 3, 4, 1, 2, 3. Oh, whoa. Sorry about that. Where's my pencil? There it is. And -5, 4. And -1, 7 is somewhere up here. Okay, so if you see these ordered pairs graphed on a graph, the third way to determine whether this is a function, if this relation is a function, is to determine, or is to simply take your pencil and move it. I wish I could do it on this screen, but I can't. But if you move it across the graph, if you literally lay it vertically on your paper and move it across your graph, the pencil will never touch two of those points at one time. That means, okay, we call this thing the vertical line test. If your relation passes the vertical line test, then your relation is a function. That means if you put your pencil vertically on your paper and you move it from left to right across your paper, if your pencil never touches two of those points at the same time, then this guy is a function. I'll show you that in person tomorrow as well. But let's move on. Okay, number 2 says determine whether each relation is a function. So maybe pause it here and I didn't put my points on for number 3, so let me put those on for you. And maybe try and do 2 and 3 on your own, and then come back and I'll talk about them. Sorry, this was man, I forgot to put my graphs on here. That and that and that and that and that and that and that. Okay, so take 2 and 3, give it a go. All right, so number 2, you could have looked at your ordered pairs and said, well, my domain values in these two ordered pairs are the same. And since they're the same, we should be looking to see, oh, guess what? My y values or my range values are different. So if you look at your definition of function, you'd realize that this guy's not a function. And I'll even write it out for you. Not a function because, can anyone tell me why? Because each domain value is not paired with W slash means with only one value in the range. I'm getting better at this writing thing, huh? So this is not a function because we have one of our domain values, 2, is paired with more than one range value. Okay? You need to know that definition of a function so that you can determine whether each relation is a function. Popping over to number 3, this one was pretty easy because all you had to do was the vertical line test. So take that pencil, start on the left-hand side of your graph, place it vertically on your paper, and just move it from left to right. Is there any point at which that pencil hits 2 points at the same time? Right off the get-go, maybe I should have kept that red. Right off the get-go, your pencil should have come across both of those points right there at the same time. That means that this guy is not a function. Okay? Not a function. Man. Sorry about that. Not a function. Why not, people? All you have to say is because it did not pass the vertical line test. B/C is because our relation doesn't pass the vertical line test. Alright, we're doing alright here, people. Got one more to go. Doesn't pass the vertical line test. Alright. We'll talk a little bit more about that tomorrow as well. Number 4. It says the table shows the water pressure as a scuba diver descends. That means dives deeper into the water. It says, do these data represent a function? Please explain. If you think you know what you're doing, pause me for a minute and think about this one on your own. Well, we can look at this in several different ways. If you don't like seeing this as a table, you can either graph these points. So I'm going to guess. We're going to say 0, 0 is a point, and 1, 62.4 is somewhere like right there, and then 2, 124.8, and then 3, 187.2, and you could graph all these points, okay, and say, hey, does this relation, because I turned each of these guys into ordered pairs, I hope you realize what I did there. I said 1, 62.4 is an ordered pair, and 2, 124.8. If you're a more visual person, you need to see it on a graph. Hey, graph each of the points, and then do the vertical line test. Put your pencil vertical on your paper, slide it across. Does it ever hit 2 of those points at once? The answer should be no, it does not, which means this data does represent a function, okay? Because each, you could say because it passed the vertical line test, or because each x value, or each domain value, is paired with exactly one range value, or one y value. Now, some of you are thinking, Mr. Dudek, you did more work than you needed to. That's correct, I did. Some people are visual, though, and they need to see this. If you don't need to see this, and you can just look at these, kind of like we did in number 2. Hey, we've got a set of ordered pairs. We've got a relation, for sure, because this is 0, 0, and this is 1, 62.4, and this is 2, 124.8. Just look at your domain values, your x's, 0, 1, 2, 3, 4, 5. Do any of those repeat? Since the answer is no, obviously each of these guys is paired with its own y value, okay? So if you wanted to look at it that way, you could have easily said, yes, this data represents a function because, and it's the same answer, guys, each domain value is paired with exactly one range value. Okay, last question. Describe how water pressure is related to depth. Well, you would probably say as depth increases, Sorry. Almost done here, I promise. As depth increases, so does water pressure. That is how the two things are related. The deeper you go, the more water pressure that exists. It's kind of like when you're swimming to the bottom of a swimming pool. The deeper you go in the deep end, the more your ears start to hurt. Okay, it's because there's more water pressing down on you, and your head can't really handle that. Okay, folks, we've done pretty well here.